Hi, welcome to Science Shop. Today we're going to be talking about how a refrigerator works. First of all, let's define what a refrigerator is. It's a device that transfers thermal energy from a cold place to a hot place. Now, if you look at the definition of heat, heat is the transfer of thermal energy from a warm object to a cold object. So what this is doing the opposite, and it's using electrical energy to do this. So let's just have a look at how it all works. So this is our refrigerator, and we've got food inside of here. And the food, when we put it in, it's warm. And what happens is you've got this pipe. So there's this one continuous pipe which goes all the way around, all the way like so, and through there. Okay, so there's that pipe. And inside of this pipe, you have a volatile liquid. It's something called a coolant, actually. And what this is a liquid that can very easily turn into a gas, and also as a gas it can very easily turn into a liquid. So this liquid absorbs and releases thermal energy very quickly. So how does it all work? Well, you put the food in, and through the process of convection and radiation, it's giving out all this thermal energy, and it's absorbed by the coolant inside of this pipe. So in the pipe you've got a cold liquid, and it's absorbing the thermal energy from the food, and it's going from a cold liquid into a cold gas. And then it goes all the way around here, all the way down here, and into the compressor. Now when you compress a gas, what you're effectively doing is you're increasing the temperature. This is known as Charles's law, but we're not going to get into that. I do have a separate video on Charles's law. So this compressor squeezes the gas and increases the temperature. So from the beginning, you have a cold liquid, absorbs the thermal energy, turns into a cold gas, goes into the compressor, and then it turns into a hot gas. This is then pumped outwards down here, and you have these vent fins. Now these vent fins increase the surface area, so it just spreads it all out, so it's able to release all of the thermal energy to the atmosphere at the back, to the air at the back, okay? And that's why if you put your hand around the back of a fridge, it's actually quite hot. It's all the thermal energy from the coolant being released, okay? So just to reiterate that, these vent fins increase the surface area, allowing the thermal energy to escape into the air. So now it went from a hot gas, loses all of its thermal energy, and then it turns into a cold gas around here. And then you have this expansion device which does the exact opposite of this compressor. So what it does is it expands the gas, reducing its temperature and therefore condensing it back into a liquid, and then it starts all over again. It's all over here again. So just from the top, what happens is you put food in, it releases thermal energy, it's absorbed by the cold coolant liquid inside of these evaporator coils. What then happens is the liquid turns into a gas, gets pumped into here, into the compressor squeezes it, raising its temperature, gets pumped outside where the vent fins increase the surface area. It releases the thermal energy, cooling the gas down. The expansion device expands the gas, cooling it down even more, condensing it back into a liquid, and the whole process starts all over again. I hope that makes sense. Thank you very much for watching. Goodbye.